Mole concept, the mole and molar mass of a substance. Hello class, I hope you are doing fine. Before we begin, please ensure that you have the following relevant materials with you. Okay, you will need your notes chapter 8b, a calculator, and the periodic table. Okay, you may pause the video now to ensure you have the materials. All good? Okay, so as usual, the top will always show the page number and subtopic. If you see any underlined words, please fill it in your notes. If you see any highlighted words, you may choose to highlight them. And finally, if you see any scribbles or red words, you can add on to your notes. Alright, let's go. First up, we will talk about the mole. Okay, page 1, the definition of the mole. A mole is a unit of measurement for very small particles such as atoms, molecules, ions, and electrons. Okay. It can also be understood as a unit of counting, a number of something. Okay, let's see some unit of measurements that you've probably seen before. Okay, we have the pair, dozen, a ream of paper, million, and more. What does a pair mean? How many number of items when I say there is a pair of something? Okay, that's right, a pair is two of something. How about a dozen? It means 12 of something. And a ream of paper, there are 500 sheets of paper in a ream of paper. And what does a million mean? Okay, a million is 1 followed by 6 zeros, or 10 to the power of 6. And a mole means 6 times 10 to the power of 23. In chemistry, when we say 1 mole, that means it is equal to 6 times 10 to the power of 23 particles. This is also called the Avogadro's constant. Okay, and sometimes it's also known as the Avogadro's number. Sidetrack a bit. How big is 6 times 10 to the power of 23? That is 600,000 billion. In comparison, the world population is about 7.6 billion. If we think about it, that would mean we need 79 trillion Earths to match it. And in our galaxy, we only have a quarter of a trillion stars. Okay, we will need about 300 times more Earths than there are stars in our galaxy. You're probably thinking, do we need a lot of a substance to get this number of atoms or molecules? Actually, it is the number of water molecules in only about 4 teaspoons. So think about it. The next time you drink a cup of water, you're drinking more molecules of water than there are stars in our galaxy. If you look at page 2, okay, we're going to make a comparison between 1 spoon of sugar and 1 mole of sodium atoms. Okay, the mathematics involved in mole concept is quite simple. Let's say I have 1 spoon of sugar, and in that spoon, the number of sugar particles is 60,000. And in 1 mole of sodium atoms, the number of particles would be 6 times 10 to the power of 23. So, if I have 2 spoons of sugar, how many particles will I have? Okay, that will be 60,000 multiplied by 2, and we'll get 120,000. Similarly, if we have 2 moles of sodium atoms, the number of particles would be 6 times 10 to the power of 23 multiplied by 2, and that will be 12 times 10 to the power of 23. Then we can also have fractions and decimals of spoons or moles. So in 0.5 spoons of sugar, the number of particles would be 0.5 multiplied by 60,000, and that would be 30,000. In 0.5 mole of sodium atoms, the number of particles would be 0.5 multiplied by 6 times 10 to the power of 23, and that will give us 3 times 10 to the power 23. Okay, we can also talk about the mass of 1 spoon of sugar or the mass of 1 mole of sodium atoms. The mass of 1 spoon of sugar is given to be 14 grams, and the mass of 1 mole of sodium atoms would be 23 grams. So, if I have 3 spoons of sugar, what is the mass that I will get? And it will simply be 14 times 3, which is 42 grams. Similarly, if I have the mass of 3 moles of sodium atoms, it would be 23 multiplied by 3, and I will get 69 grams. If I have 0.5 spoons of sugar, the mass of 1 spoon of sugar being 14 grams, 0.5 spoons of sugar would be 7 grams. Same thing, 0.5 moles of sodium atoms would be 0.5 multiplied by 23, and I will get 11.5 grams. Okay. We can also do the reverse. Given a mass of a spoon of sugar, or given the mass of 1 mole of sodium atoms, how many spoons or moles do I have respectively? Example, given 28 grams of sugar, how many spoons of sugar would that be? Okay, to find that, okay, it is 28 divided by 14, which is 2 spoons of sugar. Okay, similarly, given 46 grams of sodium, how many moles is that? Okay, it's also 2 moles of sodium atoms, which is 46 divided by 23. And if I have 35 grams of sugar, that will be 35 divided by 14 spoons of sugar. That will be 2.5 spoons of sugar. And finally, given 34.5 grams of sodium, how many moles of sodium atoms would that be? Okay, the working is 34.5 divided by 23, and I will get 1.5 moles of sodium atoms. Right, as you can see, at least for the start, to find mole calculations is quite easy mathematics of multiplication and division. We'll now move on to the molar mass of a substance. Okay, on page 3, we'll discuss on molar mass. But before that, a bit of English. A molar can refer to the large flat teeth at the back of your mouth. Okay, but in chemistry, the molar means relating to 1 mole. Okay, something like a circle, okay, is related to circular, and mole related to molar. So for example, a box that looks like a circle, you can say it's a circular box. Similarly, the mass of 1 mole of substance, you can say is the molar mass of the substance. Thus, the molar mass is the mass of 1 mole of a substance. It has the same numerical value as the relative atomic or molecular mass of the substance. It has a unit of grams per mole. Okay, so what does this all mean? Let me give you an example. If I have a weighing balance and I put 1 mole of water on the weighing balance, okay, the relative molecular mass of water is 18, and the mass of 1 mole of water will be 18 grams. Okay, this is what it means by the molar mass has the same numerical value as the relative molecular mass of the substance. So the molar mass of water is 18 grams. Thus, the relationship is as follows. It is encompassed in this formula triangle. Mass of a substance in grams is equal to the MR of the substance times the number of moles. Okay, for those who don't know how to use the formula triangle, okay, I will explain. Let's say I want to find the mass of a substance. Okay, I will cover up that part of the triangle, and you can see that, okay, it will be equal to MR times the number of moles. Okay, sometimes the question will ask you how to find the number of moles given the mass and the MR of a substance. If you cover up that part of the formula triangle, the number of moles is mass over MR. And lastly, if I want to find the MR of something, as you can see from the formula, it will be equal to mass over number of moles. And that's how you use the formula triangle. And these are the three equations that you can get from the formula triangle. So some examples of using this formula triangle. Part A, find the mass of 2 moles of carbon dioxide. Okay, if you refer back to the formula triangle, I need to find the mass. To find the mass, I will need to have the MR and the number of moles. Okay, the number of moles is given in the question, 2 moles. So what I need to do first is to find the MR. And the MR of carbon dioxide would be 12 plus 16 times 2, which is 44. Remember, the MR can be found in the periodic table by looking at the bigger number for each element. Thus, the mass of carbon dioxide for this particular case, a reminder, is the MR times the number of moles. The MR is 44 and the number of moles is 2, so it's 44 times 2 and we get 88 grams. I'll give you some time to write down the workings. Okay, moving on. Part B. Find the number of moles of iodine I2 in 254 grams of iodine. So you can see once again from the formula triangle, I want to find the number of moles. Okay, and that means I need to find the mass in grams divided by the MR. So once again, I need to find the MR of I2, and that will be 127 times 2, which is 254. Therefore, the number of moles would be the mass in grams over the MR, and that will be 254 over 254, which gives us 1 mole. Okay, try checkpoint 4 on your own, and I'll see you in part 2 of this lesson.